Alright, it's lunchtime, so if we get a distraction I might have to stop suddenly, and we'll see if we can't get it all the way through. If there is more than one valid Lewis structure for a molecule, we can't discount it and say that it doesn't work. We have to accept that it does. And so we call these resonance structures to each other. An example of this is the polyatomic ion NO3. Okay, I'm going to introduce something here called formal charge and how to look at this, and it's actually a really nifty thing. I know I have a nitrogen and I have 3 oxygens. My nitrogen should have 5 valence electrons, and each of my oxygens should have 6 valence electrons, which means I should have 23 electrons. I have this negative charge here, so I'm going to add 1 to that, so I'm going to have 24 electrons total in this molecule. Nitrogen is the one that wants the most bonds, so I'm going to start it in the middle, and I'm going to put my 3 oxygens off of it. And then I'm going to start adding electrons. So I've got 2, 4, 6 electrons. I'm going to start adding electrons until I get all the way done. So there's 8, 10, 12, 14, 16, 18, 20, 22, 24. And ignore this one, I didn't want to put that one there. Okay, so that is a valid Lewis dot structure for this element. What we see here, however, when I look at this, I can say that it does not follow my octet rule, right? Because my nitrogen only has 6. I'm going to come over here to my charges, and I'm going to look at their formal charge. Here, half of these are from my nitrogen, half of these bonds are, so it has 3 actual electrons. So this is my valence electrons, this is my actual electrons. This oxygen has 7, and so do all the other ones. So if I look at the difference here, this is a +2 charge, and these are all -1s. So I have huge discrepancies in charge here. I want to keep these numbers as low as I possibly can. So this is one valid Lewis dot structure. Let's look at a second one. Here, if I go with my nitrogen and I put my 3 oxygens on there, and then I know that I kind of messed up before that, and I want to make sure that this has its octet, so I'm going to double bond that. So that's 8 electrons now, so I'm going to go 10, 12, 14, 16, 18, 20, 22, 24. So I have the 24 that I need. And let's look at their formal charges. This is what I'm calculating over here. This one has 4 now. Right? I cut these in half. I've got 1 there, 1 there, 1 there, and 1 there. This oxygen has 6, and the other 2 both have 7. So I have +1, 0, -1, -1. So this is a smaller number, so this is much more like much more likely to happen. Alright, that's not all though. Sorry, I got some on my screen. I can also draw this this way, and I can also draw this this way with the exact same results. So I would say that these 3 resonance structures are all equal in possibility and are all fairly good, and so my actual one is going to be something kind of in the middle. something like that, that it's a combination of these three valid structures that is probably something very close to what it actually looks like. All right, so it has 4 resonance structures. 3 of them are very likely. 1 of them is not very likely at all because of the higher formal charges that we have in it. We always want to minimize our formal charges. Let's look at one other one.
Maddie Jones, come to the front office. Maddie Jones.
Maddie Jones is in trouble. It's going to be Zenon Tetroxide. So xenon is a noble gas, so it is going to bring 8 valence electrons. Oxygen is going to have 6, so I'm going to have 26 electrons in this. I can draw this. I always start with my individual bonds, and then I start adding electrons. So I've got 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All right, so we get everything there. My xenon now has 1, 2, 3, 4, 5. Each of my oxygens have 7. So this is a positive 3, a minus 1, a minus 1, and a minus 1. So that's a fairly large thing, so we wouldn't expect this to be the best structure. Let's see if we can't make a better structure. So xenon is 8, 6, 6, and 6. Now my xenon has 1, 2, 3, 4, 5, 6. My first oxygen has 6, and my other oxygens have 7. So this is a plus 2, 0, minus 1, minus 1. So this is better. And we can redraw this one with the double bond down and with the double bond to the left. And all the lone pairs on there as well. So this has 3 resonance structures which are equal in value. But we have one more, remember, because we can fill that up to have at least 6 lone pairs on it. Or 6 electron spots. So I've got 1, 2, 3, 4, 5, 6. And if I look at this now, my valence electrons, my formal charge, I've got 2, 4, 5, 6, 7, 6, 6, and 7. So this is a positive 1 and a negative 1. So this is by far my best option. I can also draw it like this, and I can also draw it like this, so I still have my 3 valence possibilities there. This is the most likely possibility, and it also has the least, because it has the least amount of difference in its formal charges.